Assalamualaikum and hi to my lecturer, Cik Muhammad Nazrin. My name Nurul Afiqah Binti Ishak and my matric number is 01 DPU21F1062. So for the introduction, a relief valve is like a safety guide for machines and systems. Its main job is to prevent too much pressure from building up, which could otherwise cause serious problem. Imagine it as a pressure safety net. If things get too intense, the relief valve open up and lets out the extra pressure, keeping everything safe and avoiding potential damage or accidents. These valves are crucial in various industries like oil, chemicals, and power generation. They are set to open at specific pressure levels, ensuring they kick in actually when needed. This not only protects equipments but also ensures smooth operations and prevent unexpected shutdowns. Working principles of relief valve. Firstly, the pressure relief valve remains normally closed until pressures upstream reach the desired set pressures. Secondly, the valve will crack open when the set pressure is reached. Thirdly, continue to open further, allowing more flow as overpressure increases. When upstream pressures falls a few psi below the set pressure, the valve will close again. Next types. For conventional types, is a differential pressure device. Back pressure on the outlets of the relief valve affected. They are only useful if they discharge to the atmosphere. Discharging to a relief heater is not practical as the back pressure is always varying and will affect the conventional relief valve. Next type is for balanced below relief valve. It addresses the back pressure problem with conventional relief valve, but it's not a complete solution. The balanced below relief valve flow performance starts getting impacted at back pressures in excess of 30% of relief valve set point. Large balance below relief valve cannot take more than 60 pg back pressure without it causing a failure of the bellows. Lastly, for pilot operated is not normally affected by back pressure as to its ability to pop at set. The effect of back pressure on the performance of the relief valve is also minimal. They can have up to 80% back pressure, with it only rating the capacity by 20%. The sensing line for the remote pilot must use a special pickup to allow it to capture the dynamic pressure part of the gas. Application. First, boilers and pressure vessels. Relief valves are used in steam boilers and pressure vessels to prevent excessive pressure build-up, ensuring the safety of the system and preventing potential explosions. Secondly, oil and gas industry. In oil and gas processing facilities, relief valves protect pipelines storage tanks, and equipment from overpressure situations that can occur during production, refining, or transportation. Thirdly, chemical processing plants. Chemical manufacturing plants use relief valve to prevent overpressure in reactors, storage tanks, and pipelines, safeguarding against the release of hazardous substances. Fourth, power generation. Power plants, including nuclear, fossil fuel, and renewable energy facilities, utilize relief valve to protect steam generators, turbines, and other components from excess pressure during electricity generations. Lastly, HVAC system. Heating, ventilation, and air conditioning system incorporates relief valve to control pressure in refrigerant circuits, ensuring the safe and efficient operation of the equipment. Maintenance and inspections. First, schedule inspections. Establish a routine inspection schedule based on industry standards, manufacturer recommendations, and regulatory requirements. Regular inspection help detect wear, corrosions, or other issues before they escalate. Secondly, visual inspection. Conduct visual inspection to check for external sign of damage, corrosions, or leaks. Ensure that the relief valve and its associated components are in good conditions. Thirdly, functional testing. Perform periodic functional tests to confirm that the relief valve operates correctly at the set pressure. This can involve simulating overpressure conditions to verify that the valve opens and closes as intended. Thirdly, lubrication. If applicable, lubricate moving parts according to the manufacturer's guidelines. Proper lubrications ensure smooth operations and can extend the lifespan of the relief valve. Fifth, seal inspection. Check the sealing surfaces and gaskets for wear, damage, or signs of deteriorations. Replace any worn or damaged seals to maintain the valve effectiveness. Adjustment checks. Verify that the relief valve set pressure is within the specified range. If adjustments are necessary, follow proper procedures and documents any change made. In summary, relief valves are like safety superheroes in factories and machines. Their main job is to make sure things don't get too pressurized, preventing explosions or damage. They quietly sit in the background until there's too much pressure, and then they open up, releasing the extra pressure to keep everything safe. These valves are used in all sorts of industries, from making sure boilers don't explode to keeping chemical plants safe. But for them to work well, we need to check them regularly. Think of it like taking your car for a checkup. We need to make sure relief valves are good condition, shape, open and close at the right pressures, and don't have any wear and tear. So, relief valve might be small parts, but they play a hug role in keeping our machines and process safe and sound. Regular checkups and a watchful eye on them ensure they continue to be the silent hero in our industrial world. So, relief valve ni benda yang diam-diam ubi berisi. Kiranya part yang paling tak dikenali ramai, tapi dia sebenarnya boleh bagi safety, bagi good condition dalam machines, sebab dia boleh jaga pressure.